So I'll do question number 7 now. In the 7th question, you have this expression, and you can see there you have every way y by x. So I've expressed in dy by dx equals to some expression. That's the first step. What's the next step? Put y by x equals to v. So what is y? Vx. What's the differentiation? Dy by dx. V as it is, here 1 plus x into dv by dx. Product rule on the right hand side. You know now. Next step, call this as 1 and let's write by 1 here. Left hand side is replaced by this much. So I'll write here v plus x into dv by dx. On the right hand side, y is replaced by vx. So this x as it is, this is cosine v plus y is replaced by vx. So here vx, this is sine v upon y is replaced by vx. This is sine v minus x into cosine v. And here you have y by x equals to v. So here just v in the numerator. Fine. Now you can see that there is x common here in the numerator. You can find this x common, and it will get cancelled. Then it is purely in v, and I'll take v on the other side. So x into dv by dx equals to, I'll just open the bracket. So v into cosine v plus here v is there, remember. So v square into sine v upon v sine v minus cosine v. And this v goes that side, so this is minus v. What I did, just take x common, it will get cancelled. And multiplying v with this bracket. So v cos v, v square sine v, and so on. Now take the LCM here. So x into dv by dx equals to v cosine v plus v square sine v minus v into v square sine v plus v cosine v upon, we have this v sine v minus cosine v. Okay. Now here this will get cancelled and this will be double, remember, 2v cos v. So we have 2v cos v upon v sine v minus cosine v. Left hand side is x into dv by dx. Now next step is variable separable form. Take this expression over here and x dx over there. I'll keep this 2 as it is. So now the next step would be here. You have v sine v minus cosine v upon v cosine v equals to 2 as it is. X will go down, 1 upon x dx. Right? This is which form? Variable separable form. Now what we do? We just integrate it. So I'll write integrating. Let me write integrating. So we'll just integrate it. So integral of, here I'll do individual division. So this is just tan v, you can see, minus 1 upon v dv equals to 2 as it is, integral of 1 upon x dx. So here you know integral of tan, which is log of mod of sec v minus this is log of mod of v equals to 2 times this is log of mod of x. Now everywhere your log functions, I'll just write log c instead of c as a constant. So integration is over, we'll just simplify. So here log of sec v upon v equals to, this 2 will go in power. So you have log of x square into c. addition becomes multiplication, subtraction becomes, division here. Now log will goes away from both the sides, so you have sec y by x upon y by x, putting the value of v equals to cx squared. We have eliminated log function, so sec of y by x, this will go that side, so 1x will get cancelled, so you have c xy. If you want one more step, you can take cos over sec over there, so 1 equals to, this will be c into xy into cos of y by x, which is a required solution, remember, of the given differential equation. This is in fact the general solution. If you look at it back side there, you have c on the other side, so you can just write like 1 by c, and you can call that as some new constant c dash, and you can write like this. This is also correct, remember, right? If you want to see just back side answer, but there is nothing wrong if you have written like this. Fine. So this way you can solve the differential equation. The question number 8, you can see that y by x is involved, so it has to be homogeneous differential equation, remember. Here you see power 1, power 1, power 1, power 1, power 1. Everywhere exponent or power of variable is 1, so it's a homogeneous differential equation. What's the first step? Get the dy by dx. So x into dy by dx, I'll take these two terms over there, y minus x into sine of y by x, dividing by x. So dy by dx equals to y minus x into sine of y by x by x. So it is in which form? Dy by dx equals to some function. What's the next step now? Put y by x equals to small v. So what is y? Vx. Now differentiate it. So here dy by dx equals to v as it is, here 1 plus x into dv by dx, by product rule on the right hand side. Call this as 1, and you write by 1, v plus x into dv by dx equals to, what is y? That is vx, minus x into sine v upon x as it is. Y is replaced by vx. V plus x into dv by dx, v minus sine v. You can see that x will goes away. Now again this, v will get cancelled, and then you just express in variable separable form. So sine v will come down, so 1 upon sine v dv equals to 1 upon x dx with minus sign. This minus sign is there. This is which form? Variable separable form, remember here. So you just integrate it, not a big task for you now. This is cosec x. Integral of cosec. Do you remember integral of cosec? It's very standard formula. Integral of cosec, you know very well how to do that, right? And then just compare with backside answer. I did almost for you. The next question, 9th number. There are two terms involving dy, so I'll take dy common first. So y into dx plus, here you have x into log of y by x minus 2x into dy equals to 0. Fine. Now you can see that it is a homogeneous differential equation. 1, 1, 1, 1, 1, or y by x is involved. So it is a homogeneous differential equation, remember. So what's the first step? Get the dy by dx. So I'll take this expression over there. So this is 2x minus x into log of y by x into dy. Just taking this expression over there. So therefore dy by dx equals to, here y will be over there, this will come down, 2x minus x into log of y by x. Fine. Dx into y and this expression into dy. Now you can see that it is in the form of dy by dx equals to some expression. What's the next step? Put y by x equals to v now. So what is y? Vx. Therefore dy by dx by product rule, v as it is, derivative of x with respect to x1, x as it is, dv by dx. You know, we usually call this as 1, and therefore by 1 dy by dx, that is here v plus x into dv by dx, that's equals to y is replaced by vx. So vx upon 2x minus x into, you have log v here. Take x common, it will get cancelled, and take v on the other side. So x into dv by dx, v upon, this is 2 minus log v, x will go away, and I'm taking v on the other side. So here you have x into dv by dx equals to v as it is minus 2v plus v into log v upon 2 minus log v. Fine. So if I just simplify right hand side, here it will be minus v plus v log v upon 2 minus log v. So here let me integrate it after just separating the variables. So integral of 2 minus log v upon v minus v log v into dv, minus sign I've kept on the right hand side, integral of 1 upon x dx. Just observe this, you must get this from the previous step, remember. Now this is very simple. Here do individual division. So if I do individual division, this is 2 upon v minus v log v minus here log v upon v minus log v here into v equals to minus 1 upon x dx. Now take v common and just write in the numerator. So here I can write 1 upon v upon 1 minus log v. Fine. What I did, just taking v common and I wrote there in the numerator. Here let me keep this one as it is. Now how do we integrate left hand side function? That's a question. So if you think for a while, this is more or less in f dash upon f form. Differentiate this with some plus or minus sign, you will get the same thing. I think if you differentiate this f with some plus or minus sign, you will get the same. And this you know, so complete it. You can do it now. I did almost for you. Okay. Question number 10, next question, 10th question. Now, this 10th number is a little bit different than the earlier questions because there x by y is in bold. E raised to x by y into dx plus e raised to x by y into 1 minus x by y into dy equals to 0. Now, as I told you earlier, what we do is here, this is of course a homogeneous differential equation, remember, homogeneous differential equation. But here we are not going to express in which form? Dy by dx form. We are going to express in dx by dy form. So I'll take one term on the other side here. So minus e raised to x by y into 1 minus xy into dy. Now we are going to express in which form? Dx by dy form, as I told you in the theory portion. So numerator expression will be this only. I'll take minus inside. So e raised to x by y. I'm just taking minus inside. So x by y minus 1 upon this will go down 1 plus e raised to x by y. Right? In which form I have expressed? In all earlier questions you had expressed in dy by dx form, remember. But in this question we have expressed in dx by dy form. Reason is you in the question itself you have x by y form. We call this as 1, and now we use the substitution. Which substitution? Put x by y equals to v substitution. Therefore x equals to vy. Now we differentiate with respect to y, remember here. Differentiating with respect to y. That's the difference. So derivative of x with respect to y, dy by dx. Product rule, v as it is, derivative of y with respect to y1. Now y as it is, differentiation of v with respect to y, that is dv by dx. Right. Use this. So from 1, on the left hand side we are going to place this. So v plus y into dv by dy equals to, what's right hand side? E raised to v into v minus 1 upon 1 plus, e raised to v. Fine. So you can see that now it is reduced in v and y. Earlier we had x and v, Take v on the other side. So y into dv by dy equals to v into e raised to v minus e raised to v upon 1 plus e raised to v minus v. So y into dv by dy equals to, I'll just take LCM, v into e raised to v minus e raised to v minus v into e raised to v upon 1 plus e raised to v. So this will get cancelled. Just take minus common. So if I take minus common, you have e raised to v plus v upon 1 plus e raised to v. Y into dv by dy. Now you can separate the variables. How will separate the variables? You take this expression over here. 1 plus e raised to v upon e raised to v plus v into dv equals to, here minus sign as it is, 1 upon y dy. This y will go down and you have into dy. This is now which form? Vs form, variable separable form, Okay. And now we integrate it. So next step is you just integrate it. Okay. So we are integrating now here. So you have integral of 1 plus e raised to v upon e raised to v plus v into dv equals to minus integral of 1 upon y dy. So what is left hand side? Which is, very simple. Which form? If you differentiate this, you will get exactly this. So if this is f, then this become f dash. So you have log of mod of e raised to v plus v. What about this? Minus, this is nothing but the log of mod of y. And here you can write log c as a constant instead of just c, because at both the places you have log function. So log of e raised to v plus v, take log common, so here this is log of, the subtraction becomes division, so c by y. Put the value of v and simultaneously we are going to eliminate this log function. So e raised to, what was v? It was x by y, remember, plus what is v? That is nothing but x by y here, equals to c by y. So just take y as LCM, y into e raised to x by y plus x equals to c, which is here a required solution. Where c is arbitrary constant. This is a solution of a given differential equation. Fine. Now question number 11 to 15 are about particular solutions. So there I'll do just one, remaining you can try. You know how to do such questions about particular solutions. So let me try for example question number 11 itself. I'm doing 11th. Up to this you need to do, then you need to get the c using that condition given in the question. X plus y into dy plus x minus y into dx equals to 0. And then you have some condition in the question. So what's the first step? As we did, have you noticed that it's a homogeneous differential equation? 1, 1, 1, 1, 1. So if you want, just you can write homogeneous differential equation. Get the dy by dx. So I'll keep here dy as it is. I'm taking this term over there. So y minus x into dx. Taking this one over there. So dy by dx equals to, here y minus x, and this will go down, x plus y, right? What's the next step now? Put y by x equals to v substitution. So y equals to vx, and then dy by dx equals to, here v plus x into dv by dx. Call this as 1. Now you know how to do further. Okay, so I'll not be doing further. I'll go to next question number 13. Let me do question number 13. That's about trig function. So I'll do that. X into sine square y by x. You can see y by x is involved, so it has to be homogeneous function. Dx plus x into dy equals to 0. There is some initial condition that you will be using at the end, remember. Now what's the first step? Get the dy by dx. Because this is a homogeneous differential equation, homogeneous differential equation. So dy by dx equals to, you have minus sign here. So this will be in the numerator, x into sine square y by x minus y. This will be in the numerator, and this x with dy go down, right? I think this is clear to you. Okay, now what's the next step? Put y by x equals to v substitution. So what is y? Vx. Product rule on the right hand side, dy by dx, v plus x into dv by dx. You know this, number of times we did it. Call this as 1, and you write from 1, left hand side is replaced by this one. So by 1 here, what is left hand side? That is v plus x into dv by dx minus here x as it is, but this become v, and y is replaced by what? Vx upon x. So x will get cancelled. So finally, let me write one more step here. Minus, I'll take inside the bracket. So this is minus sine square v, minus minus will be plus, and you have v. Okay. So this v we will get cancelled. Now variable separable form. Before I do that, let me write one more step here. This I'll take down here. So 1 upon sine square v, which you know cosec square v into dv equals to minus 1 upon x dx, right? This is which form? Variable separable form, you know. Which form? Variable separable form, remember. So integration now, integrating. So if you integrate this, here you have cosec square v dv minus integral of 1 upon x dx. Fine. What's the integral of cosec square? You know. Minus cot x. You know, here it is minus cot v, of course. Here you have minus log of, let me write mod of x here, plus the constant c. Right, you can call this as 2 if you want to call. This is a general solution, remember. This is a general solution. Now you have some condition in the question. We use that condition as we did in earlier method. We find c and we place there. Now what about the condition? Have a look at the given condition. So you are given that when x is 1, y is pi by 4. So let's place there. So you can write by 2. This become, when I put this, you know, indirectly this is nothing but what? Y by x. Right? So this become cot pi by 4, which is 1. Minus, this is log 1, which is, you know, 0, plus c. This is 0 here, and therefore c becomes minus 1. So from 2, particular solution is here. Particular solution is minus cot v. V means y by x. V is y by x. Minus, this is log of mod of x. This is minus 1. So I place the value of c, remember, you know this, we did it earlier. So you can take minus common and you can cancel it. So this is cot of y by x equals to log of mod of x plus 1. This is a required solution, remember, required solution. And it is correct, remember. If you look at it back side, what they did further is, this one as it is, here, this you can write log e, you know, log e to the base e is 1. And then you can use the product rule property here. So this is e into x, cot of y by x equals to this. This is also correct. This is what your backside answer. But if you leave it in this form, there is nothing wrong, remember. You can keep in this form, the required particular solution, you know. Just I've explained for your information. If you see the backside answer, it is in this form. So whether you write this or this, both are same, remember. Okay. Question number 15. You can just observe that it is a homogeneous differential equation, because in each term you can see that you have same power. Here 1, so total power 2, 2 and 2. Constant has power equals to 0, you know. Therefore it is a homogeneous differential equation. What's the first step? Get the dy by dx. So I'll take this one over here. So 2xy plus y square upon 2x square. Fine. So it is in the form of dy by dx equals to some expression. Now what's the next step? Put y by x equals to v substitution, you know. What is y? Vx. Now variable separable form, you will do at the end. So therefore dy by dx equals to v plus x into dv by dx. This is product rule. V as it is, Derivative of x is 1 here, x as it is, and dv by dx. Call this as 1. And therefore, by 1, I'll place the value on the left hand side. So it is v plus x into dv by dx. 2 as it is, x as it is. Instead of y, we are going to put vx. So x squared, and this is v. What is y? V squared x squared upon 2x squared. So you can see that this x squared you can take common and it will get cancelled with this. So x dv by dx equals to, you have 2v plus v squared by 2. This y I am taking this side, so minus v, remember. So x dv by dx equals to 2v plus v squared minus 2v upon 2. Now here this will get cancelled. So x into dv by dx equals to v square by 2. It is in VS form, variable separable form. So here 1 upon v square into dv equals to, if you want you can take 2 over here, let me take 2 also over here, 1 upon x dx. So sorry, here now it is in variable separable form. Now we can see that to integrate this is not a big task. So how we'll integrate this? That can be done very easily because this is very well known standard function. So integrating this, if you integrate this 2 as it is, what's integral of 1 by v square? Minus 1 by v equals to, this is log of mod of x. Let me write plus c as a constant. Fine. And therefore here minus 2, putting the value of v, y by x. So x will be here, log of mod of x plus c. This is general solution. You have some condition in the question. What about that condition? Now when x is 1, you are given that y is 2. This is a condition given in the question. We use this condition and we get the c from 2. So by 2, here minus x is 1, y is 2. So this is just 1. Log of, what about here's x1. So log 1 plus c. Log 1 it is 0. So c equals to minus 1. So from this equation you will get the particular solution. So therefore particular solution here is minus 2x by y, just we are placing the value of c here, equals to log of mod of x, what c, minus 1. Fine. So you can write this as a required solution. This is a required solution, or you can just express in the form of this also if you want. If you can write like this, y equals to 2x upon 1 minus log of mod of x. Both are same, remember this is same as this. This is also correct, or you can write like this. Whether you write this or this, both are correct. So this is required particular solution, remember, using initial condition given in the question. Fine. Now let's see question number 16 here. So the 16th number, the homogeneous differential equation is in this form: dx by dy equals to h of x by y. Can be solved by taking which substitution? So obviously, as we did earlier, you need to put this equals to v. Put x by y equals to v. That means x equals to vy, and which is nothing but which option? C, remember. The same method we have followed in which question? question number 10. That's what we did in the 10th question, which is an important example. Question number 10. Okay. About next number, question number 17. Which of the following is a homogeneous differential equation? That's a question. What about the first one? From the options we are doing, is a homogeneous differential equation? Answer is, you see here, power of 4x is 1, 6y again 1, plus 5 power is 0. All the terms are not having the same power, so not a homogeneous. Not homogeneous, remember. Go to the option B. Obviously it is not, because xy has power equals to 2 total power and x cube has total power equals to 3. So again, not homogeneous, remember, not homogeneous differential equation. Third one, x cube 2y squared, x cube plus 2y squared, here 3, here 2, so not a homogeneous differential equation. D, if you look at, there y square has power equals to 2, then you have, this is into dx, plus here x squared power 2 minus xy total power 2 minus y squared total power 2 into dy equals to 0. So therefore this is a homogeneous differential equation. Homogeneous differential equation. Therefore D is the correct answer in this case. So the homework is now the complete solution of 9.5. Solve the remaining. You have realized questions are in some of the cases might be a little bit lengthy but not difficult. Integration plays crucial role here, remember.